programming method has many advantages over the enumeration scheme. One of the main advantages is being the reduction in the dimensionality of the problem. We are going to reduce the dimensionality of the problem. Suppose we have found units in a system, any combinations of them could serve a single load. There would be the maximum 2 power n minus 1 combination. 2 power n, say if you take the 4 generating units, okay, so 2 to the power of n minus 1, so 4, so 2 to the power of 4 minus 1, it is 15 combinations to test. However, if a strict priority order is imposed, there are only 4 combinations to try. Like in the priority list method, if you are going for a strict priority list, then only 4 combination, that is priority unit 1, priority unit 1 plus unit 2, then priority unit 1 plus 2 plus 3, then priority unit 1 plus 2 plus 3 plus 4. So these are the 4 combinations, so that you can, if you are go for strict priority method, then these are the only 4 combination. Otherwise you have to go for this 15 combination. The imposition of priority list arranged in the order of full load average production cost, as we did in the priority list method. This would result in theoretically correct dispatch and commitment. Okay, only if there are certain assumptions for this priority list method, that is no load cost as 0, then unit input output characteristics are linear, are considered to be unit input output okay, cost are um, linear between the 0 and output load. There are no further restrictions. Then startup costs are to be the fixed amount. So in dynamic programming approach, we assume that a state consists of array of units with the specified units operating and the rest offline. Okay, so we are considering in matrix, that is a state consists of array of units with the specified units operating and the rest offline. Okay, so specified units alone while in operating, and the rest other operating in offline. The startup cost of unit is independent of the time. Independent of the time, it has been offline. Okay, the startup cost of unit is independent of the time. It is not dependent of time. The time we are neglecting here. Okay, so it has been offline, that is fixed amount. Fixed amount. There are no cost for shutting down a unit. But even if you take in practical, for thermal generating units, there is some cost. Okay, for shutting down the unit. Okay, workers involved, then uh, like like after shutting down, we have to take that burnt coal to ash handling plant, that is ashes to ash handling plant. Like that, many costs are involved in that shutting down that unit. But in this dynamic programming approach, we are not taking that cost. We are considering that shutdown cost to be 0, like that. There is a strict priority order in each interval of a specified minimum amount of capacity must be operating. So we are following the strict priority order. In each interval, a specified minimum amount of capacity might be operating. Like that, we are considering. And we are trying to solve the problem. A feasible state is one in which committed units can supply the required load, and that meets the minimum amount of capacity of each period. So next, coming to the forward dynamic programming approach. This dynamic programming approach to run backward in time, starting from final hour to be studied. back to the initial hour. Conversely, one could set up the algorithm to run forward in time from initial hour to the final hour. Okay, so this is the major thing in this forward dynamic program. So what we are considering is we are running that algorithm to run forward in time from initial hour to the final hour. Okay, forward approach has major advantages in solving generating unit commitment. For example, if the startup cost of unit is a function of time, it has been offline. If the startup cost of the unit is function of time, it has been offline. That is the temperature. That is the temperature. Then the forward dynamic approach is one is more suitable since previous history of units can be computed at each stage. There are other practical reasons for going forward. Okay, so what here if the startup cost of unit is a function of time, then it has been offline. It has been offline, that is temperature. Then the forward dynamic approach is more suitable since the previous history of units can be computed at each stage. There are other practical reasons for going forward. The initial conditions are easily specified and the computations can go forward in time as long required. Okay, a forward dynamic approach algorithm is shown in the flow chart. The recursive algorithm to compute the minimum cost in our k with the combination I. Okay, this is the recursive algorithm to compute the minimum cost in our k with the combination I. Okay, with our k and the combination I is given as f cost of k comma I. That is our comma combination that is given as minimizing the okay, like production cost, P cost, like F cost is nothing but least total cost to arrive the state K comma I. Okay, generally in economic load dispatch also, if you take like we are considering our main objective is to minimize the total fuel cost. Similarly, here also in forward dynamic programming also, what we are considering is we are considering the least, that is total fuel cost that has to be least, that is f cost of k comma I, that is nothing but least cost to arrive at the state k comma I. Okay, with this state, that is with the minimum cost in our k comma I, then p cost of k comma I, p cost of k comma I is nothing but production cost of the state k comma I. Next is yes cost. Okay, yes cost is nothing but transition cost. Yes cost of k minus 1 comma L is to k comma I. That is nothing but transition cost from the state k comma 1 comma L. K comma 1 comma L to the state k comma 1. So S cost is nothing but transition cost, P cost is nothing but production cost, F cost is nothing but least total cost, least total cost. So F cost of K comma I, sorry, K comma 1, sorry, that is nothing but I. F cost of k comma I is equal to minimizing P cost of k comma I plus S cost of k minus 1 comma L is to k comma 1 plus F cost okay, F cost of k minus 1 comma L. Okay, so this is the objective function. This is the objective function of this recursive algorithm. Coming to the flow chart, so first we are starting the algorithm. We are taking the k is equal to 1. Okay, k is nothing but 1. Okay, so minimum cost in each hour. So that k, we are minimum cost in each hour we are taking as first we are starting from one first hour, then as one, not hour, that is as one. Then we are calculating that formula, that is F cost, minimizing the total fuel cost. That is F cost of k comma I is equal to minimizing P cost of k comma I plus S cost of k minus 1 comma L is to k comma I. Okay, k comma I. So what we are doing is we are okay, multiple times we are okay running for do for all the states I in the period k. So for that particular period, for 24 hours of period, we are repeating this do for all the states I. Okay, for states I also, what is I here? So I is nothing but combination. So for all the state I, okay, I in the period k, we are repeating this. And next what we are doing is we are incrementing this k. We are incrementing this k, that is k plus 1. Okay, k plus 1. Next again, n feasible states in the interval k minus 1. Okay, so for all L, what we are attaining is for n feasible states in the interval k minus 1. Okay, so up to k minus 1 for feasible states we are considering. Next again we are calculating F cost. Okay, so F cost of k comma 1, that is nothing but minimum P cost of k comma 1 plus S cost of k minus 1 comma L is to k comma I. Okay, plus F cost of k minus 1 comma L. So again, what we are doing is we are doing for all x states. Okay, for all x, that is state I in the period k. So that we are repeating for this all the state. And the next we are saving the n lowest cost strategies. Okay, we are saving that answer alone for save n low cost strategies up to k is equal to m, that is for last hour. Okay, if yes, okay, if that is computed for last hour, if yes, then trace for the optimal schedule or otherwise stop. So if this condition not satisfied, so if it is yes, we are going for trace for the optimal schedule. If it is no, again we are moving this to this step. So again we are incrementing k is equal to k plus 1. Again we are doing the same step until the optimal solution is reached, until the optimal scheduling is reached. So we are tracing for the optimal schedule and we are going to stop the algorithm. Okay, the state k comma I is nothing but ith combination in the hour k. For the forward dynamic programming approach, we define the strategy as transition or path from one state at a given hour to the state at next hour. Okay, so we define the strategy as a transition or path from one state at a given hour to the state at the next hour. Now that two new variables, that is capital X and N, have been introduced. Capital X and N have been introduced. That is, X is nothing but number of states to be searched at each period, and where capital N. So capital N is nothing but number of strategies, comma path to save at each step. So X and N is nothing but X is nothing but number of states to search at each period. Then capital N is nothing but number of strategies or path to save at each step. Okay, this capital N. Okay, save N, lowest cost strategies. That capital N, that is number of strategies or path to save at each step. And this X is nothing but number of states to search each period, number of states to search each period. So each period, so this many number states we have to search. So that is what given here. So next, coming to the combinations. So this is of the neural network. Okay, a neural network in common. So in common, a neural network consists of, okay, so one input layer. So generally this is the input layer, this is the hidden layer, and this is the output layer. Okay, this is the single layer hidden neural network. So in this dynamic approach, we are okay. Most probably, we are going to solve with this neural network approach only. Then only the solution is somewhat we can made the solution as simple, or otherwise, if you are solving normally. Like as we solved for three generating units using the for theoretical calculation, if you calculate, it might be very very complex problem. That too, the combinations are as you have seen, no, the combinations are very very higher. It is not a easy task. It will take for a simple 5 unit system itself very very complex. And if you go for the combinations by solving using the your scientific calculator, then the combinations might be of very very more. It will takes more time. Okay, it will take I think nearly 10 hours like that. If you do the calculation faster, then it will take manually, I'm saying. So like it will take more hours of time to calculate for minimum unit, or minimum 4 units if you go for. Then it is very very complex problem. So that's why we are going for simply the neural network. So neural network is it's mimicking the our human brain. Okay, how the human brain is working. So how the human brain is working, like simply like that. For example, if you are going, if you are taking your finger to your small fire. Okay, like candle. Okay, you're lighting the candle, and you're taking your finger to near to that fire. So what will happen is, if you are taking your hand to near to that fire, what will generally happen is like reflex action will takes place. Reflex action, like some command will go to your brain. Some command will go to your brain. Like it is getting heated up. Your finger is getting heated up, so you can't able to tolerate. Like so that simply you can remove the hand. Simply like that, you can remove the hand. Like that, reflex action, the command is coming from your brain, so that that is given to your hand, so that you have to remove the hand. Like that, okay, we are removing the hand. So why we are doing like that is, um, okay, so that is the nature of the brain. That is the intelligent nature. That is the intelligent nature. No machine, no machine robots or do like that. Robots like you have seen in that film, robot, Rajinikanth film. In that film, what is generally happening in that is that what is generally happening in that film, that robot will like previously first designed robot. So what it will do is, it will simply do as per the commands. That robot will not think. Okay, as per the program, that robot is driving a car. Okay, so we have to give the command, put the brake, or move right or move left, like that we have to give. Then only that robot is turning that steering, and we have to tell like okay, apply brake now, like that only it is applying. Okay, there is no intelligent nature. Okay, there is no intelligent nature. So whatever the command if you are giving, then simply like that it will do. It will not think. There is thinking nature. Intelligent nature is not there, whereas human, the intelligent nature is there. Okay, so simply if a robot is working in a industry, robot is working in an industry, say for example, it has to stitch a bag. It has to stitch a bag after after putting all your products inside. It has to stitch a bag. In that scenario, sometimes due to the some wrong time, okay, so that stitch is like happening, two stitch like more stitches are happening in that particular bags, say for example in the particular bags. So in that scenario, if humans are doing, so they can like take away. They can simply take away after they know like only 10 stitch has to be done in that particular thing. Then simply like that take away. So but say for example some wrong time is happening in that particular machine. So sometimes the possibility, like if the robot is doing the same job, so what that robot will do is it will not take away. It will make that sometimes the possibility of accidents also. It will not take away. Sometimes wrong due to the wrong time, the entire process will get because there is no intelligent nature in the robot. So whatever there is one time to that robot. So it has to keep that bag for 10 minutes means, sorry, 10 seconds means it will keep that bag for 10 seconds. Then after 10th second it will take away. But there is some error. There is some error somewhat happening in the production. From that machine it is coming, the time is somewhat 1 minute 1 second is lagging, 1 second or 2 second is lagging. So within that 1 second or 2 second, so stitches making extra, so that so humans can do that intelligent thing. Even if you take like some foundries, you have to work very very careful, or otherwise you simply like that you can lose your fingers, or you can lose your hands like that, if you're not doing it properly, if you're missing the time, if you're missing time. So like it will take, that's why in robot also. Okay, so we are going for machine learning. We are going for machine learning. So in that machine learning, what that machine learning will do is it will learn. Okay, it will learn based on the previous faults. So whatever the faults it is happening, so it will learn, and it will try to rectify in the further process. Machine learning, that is called machine learning. So if you take like Google Maps, nobody is telling to Google Maps. Okay, so Google Maps don't have any like uh, uh, antennas or any receiving stations, or stations, so that it can receive the signal, and it can send the signal to it. So what how the Google Maps is operating is from all our mobile phones. What whoever using the mobile phones, or whoever using that Google Maps gadgets. Okay, so we are acting as a like a host for that particular area. So any accident happened in the particular road, or any traffic jam happening in that particular road. So who is telling to that Google server, like here there is a traffic, it may take some 1 minute of time to okay, like rectify that traffic, like that, who is telling our mobile phones, our signal from our mobile phone, who is standing first. Say for example in traffic, 10 people are standing, 10 mobile phones are using the same map or using that particular line. Okay, so the first person is okay, assume considering like that will take like 1 minute of time to clear. Then second person, he is taking like a 1 point some 10 minutes like that. So each and every person have some calculation to the distance. Okay, so where the from the where they are standing, so that automatically that command is being sent to the Google server. From the Google server, we are receiving the signal due to the heavy traffic, it will take 1.5 minutes of time or 1.56 minutes of time, like that accurately the Google is suggesting. Sometimes it might not be very accurate. Okay, so many times it may be accurate. Okay, we can't tell like Google Maps is 100 percentage accurate, 90 percentage or 95 percentage, somewhat some many times it may be accurate. And also while traveling also, so Google map, how it is telling, like it is telling to go in a shortest path. Okay, always optimal path or shortest path. Okay, so if I'm using cycle or if I'm using two-wheeler, so that is a separate thing. So if you put the two-wheeler mode or cycling mode, so it will show some very small streets, so that you can travel, you can go in optimal path, you can go in shortest path, instead of say I'm keeping a address for 10 kilometers. That particular 10 kilometers, like if you go by car, that is 10 kilometers. If you go by two-wheeler, it will take like 9 kilometers also, because Google is telling some shortest route, so that you can reduce your fuel cost also, and you can reach that place very quickly also. Okay, instead of going by for 15 minutes, you can go by 12 minutes or 10 minutes. You can save some 5 minutes of time also, like that. That is the intelligent thing. So and also, nobody is telling Google, nobody is telling the Google, and also nobody so no one is sitting there. And if you are putting a particular map address, nobody is sitting there, and nobody is guiding you to turn left, nobody is speaking to you. Okay, so that is one robot. A robot is only speaking to you. So that robot will tell like take left or take right, then go straight. After 100th meter you have to turn left, after 500 meter you have to turn right, then make a U-turn, like that. Many commands they are giving, many commands are, that is optimal path command it is giving. So direction itself, you have to move towards north direction for this 500 meters, and you have to turn south, take right, and you have to go south, like that. Many commands is giving. So that is all of one of this logic only, neural network logic with machine learning. Now they have added the machine learning also. Machine learning will learn, and it will give the command. But even neural network is a intelligent technology, so that you can go for whatever maximum combination is that, it will give the solution. It will give the solution easily. Why? Because we have programmed like that. So but a neural network, so whatever we have telling to machine, that command only it will work. Okay, so if we are giving the prior set of commands, like 2 power n minus 1 power m, like that we are giving the command means, so that particular combination only it will work, and it will give the solution. So but even though we are giving the it is having intelligent nature, but only up to this command, this combination only it will work. So it will not think based on the practical scenario. It may that neural network, it will not think, and it will not react. That is the machine learning. That is the next concept. That is the next concept. So like in free time you can learn machine learning and try to incorporate with this neural network, and you can go for the solution also. Okay. If you, this is a simple here if you are seeing now, this is a simple neural network, okay, simple neural network that we are having input layer, one hidden layer is there, then one how output layer is there. Okay. So the combinations, whatever the command we are giving, they are giving to the hidden layer. Okay. So like formulas also we are giving in the hidden layer. Okay, instead of directly getting the output, we are going for simply one hidden layer. So from that okay, neural network is calculating your task. So whatever the command, maybe you can give the command like minimize the my total cost of today. You can give like your objective function, I have to, I'm having like 10,000 rupees in my hand. Okay, I need to spend for a whole day. Okay, so my objective is to purchase these are the things. So if you frame the your objective function and simply like that, if you give to the neural network, so it can give how optimally you can utilize that amount, so that how optimally you can reduce the cost, like that also you can program. It is not you have to program like this. So whatever the objective you are giving, say you have to go for a particular temple. In the If you go for that particular temple, you have to choose the optimal path. Okay, so optimal path. So what we are doing is we are choosing the optimal intelligent Google Maps. So we are keeping, or otherwise you can program also. You can if you program all the possible ways from your home to that particular place. Then if you are giving that to neural network, so after processing, then neural network also will give the optimal path, whichever is the shortest route, so that you can reach the particular thing. But if you're programming with this, it will not tell like intelligently, but whatever the thing you program, so whatever the combinations from here, this is the one route, this is the another route, this is the another route, like that, some five combinations you are giving. So from that best combination it will choose and it will give you. So in that, any traffic is there, you have to turn again, you have to turn to this path, like that it will not suggest. Okay, like whatever the thing you are giving, it will. So similarly like that, what we are going to do in this unique commitment problem is that we are giving the formulae or the combinations over here. So that many combinations, so this input layer is given to the hidden layer. So from the hidden layer again, it is going to the output layer. So and the output layer is the output layer, you can get the combinations, so how many combinations that particular thing is having, so that this optimal possible combinations also it may give, the as a results. Okay, yeah. So this is the k minus 1 interval. So this is the kth interval, so hidden layer from the kth interval. So again it is going like k plus 1 interval. This is the restrict searched paths of dynamic programming algorithm with n is equal to 3 and x is equal to 5. So input we are taking as 5, 1 2 3 4 5. So x is equal to 5, input we are taking is 5, and the layers, number of layers, okay, that we are taking as 3. Okay, taken as 3, and we are going for this dynamic program, forward dynamic programming method. So these variables allow control of computational effort for the compute enumeration, that is the maximum number of value of x and n, that is 2 power n minus 1 combinations. Okay, 2 power n minus 1 combination. For example, with a simple priority list ordering, the upper bound on X is n, small n, that is the number of units, reducing the number capital N, which means that we are discarding the highest cost schedules at each interval of time and saving only lowest N path or strategies. So what we are doing is we are neglecting the more cost, okay, more cost, and we are choosing only the low cost path or strategies, such that no assurance that theoretical optimal schedule will be found using the using a reduced number of strategies and search range. Okay, so we are giving the search range and also the strategies also. With that strategies, it is going to found out the least cost. Okay, so if you found out the least cost generators, so you can easily say, for example, 5 generating units are there in our hand. Okay, so for an example, for simple understanding, I'm telling. So first generator cost is 1,000 rupees. Second generator cost is 2,000 rupees. Third generating cost is 4,000, 5,000, like that. So five generators we are choosing. So now you have to commit. So like from that 5 generating units, you have to commit only 3 generating units to, so that you can go for serving the load or demand. Okay, so optimal 3 generators you have to choose, optimal to 3 generating units you have to choose. So from this 5, so which is the least cost? One is 1,000 rupees, another is 2,000 rupees, and another is 3,000 rupees. So if you commit, okay, this all 3 generating units to that particular like dispatch, so that the cost might be least, and also you can manage that demand also. Okay, to meet out the demand and with the least cost, and you have to commit the least cost generators. That is the main objective function. You have to commit the least cost generators. If you simply choose fifth generator and fourth generator and third generator, with this combination if you go for, then automatically defaultly your cost of the power generation will becomes higher. If the cost of the power generation becomes higher, then that is of no use. Okay, so no need of generating, no need of running, because cost is goes like anything. Then what is the need of generating that power? So always you should go for least cost, like as our human nature. If you're going to buy a product, how you'll buy? You'll go for searching that product in 1 or 2 shops, okay, 3 shops, 4 shops, 5 shops. You'll go and ask that particular appliances rate, and you will try for online shopping also. So you will compare the cost. So this is 1,000, this is 1,100, so this is 1,050, this is 900. So they definitely will go for purchasing from 900 rupees only. 900 rupees only. Why? Because that is the least cost. Like that, you have to go for optimal cost. Then only the cost will be reducing, and you can also save the amount wherein which the tariff will be reducing. So if you say, if you take like a small example, this is a small example, like units are given, minimum and maximum operating limits are given, like incremental heat rate is given, then no load cost is given. Next, full load average cost, FLA PC is also FLA PC also given. Then minimum times, that is maximum uptime and downtime, that is given. Next, initial conditions, hours off. So which how many hours it has to be off and how many hours it has to be on for a total period of time also, that is given. Then hot and cold reserves and the cold start is also, this is also one more constraints, that is also given. Hot cold reserves, that is also given. Then load pattern is also given for 1 to 8 hour. So what is the load pattern? How the load pattern it should be? It will be given. Okay. So what we have to do is we have to find out the like optimal combinations from out of this. Okay, so if you say take like this many states, 15 states, 0 to 15 states we are taking. So this is the unique combination. This is the unique commitment. So the four generating units in the problem we have taken four generating units. So whichever the time the unit should be on. Okay, so so for time, so all the thing is zero. So for first time, so only this fourth generating unit should be in on. Okay, for second hour, only like first generating unit. These are the generating units. So your generating unit one, two, three, and four. Okay. Mm, for that generating unit, if you on this fourth generating unit, then what is the maximum net like megawatt combination? We can generate 60 megawatt. So if you on, so depends on the demand patterns, depends on the load demand. So if you on fourth generating unit 60 megawatt, it will come. If you on first generating unit 80 megawatt. So if you go for two combination, that is if you on the one is nothing but on, zero is nothing but off. Okay, for easy understanding. So one is nothing but committed generating units operating. Zero is nothing but uncommitted generating unit, that is unit shutdown. Okay, so like that third generating unit. So first and fourth generating unit. So for that two combination, what is the demand? So from this two combination, you may able to generate 140. So from that 140 megawatt, from that particular demand, that particular hour also the demand approximately will be like this one. Okay, exactly they will not generate. So if the demand is some 220 megawatt or 230 megawatt, they will go for 200 and generating 250 megawatt, like that. This hour, like fifth hour, third unit alone is on na, so 300 megawatt, like that. So whatever the combination we are giving, so like that the amount of generation also will be varying. It depends on the demand. So who will go and go here and we have to calculate manually, no, because combinations are more, unique combinations are more here. So we have seen no combination 2.54 into 10 to the power of 24 or 10 to the power of 72, like that. The Okay, 10 to the power of 74 combinations you have to do, so that you can optimally meet out the demand, so that your cost of the. So imagine the four generating units, I think you can easily do with your scientific calculator. That too, it will take some more time to calculate this. If you go take that scientific calculator and it will calculate, definitely it will take half an hour of time for do this combination, whole combination. Imagine the state what we have taken is only 15 state. If you go for more states, might be very very complex to even calculate in calculator also. So who will do this job? So some intelligent program and intelligent technique has to do this stuff. So that's why we are going for solving using this neural network method. So neural network, if you simply give the, so what combination you need and what is the input. So this many input is nothing but a generator. So this many generators we are giving to that particular neural network. Even it might be more or it might be exact, like that, to that particular thing. So or otherwise say for example 100 generators is there in the whole state, like 100 generators there. So we are inputting all the 100 generators, and based on the demand. So this particular hour, the demand is 13,000 megawatt. So 13,000 megawatt. How from this all the, so cost also we have given for the fuel cost function also we have given for all the 100 generators. So based on the cost, it will choose the particular generators, and so that we can give the command to that particular generators to operate. Okay, so entire system itself will do, need not go there, and you have to make a phone call to that particular generators, that also they will do. But sometimes that also they will do. But they will give the map, like today's, so based on this combination. Okay, so they will give the map to that particular generating stations, so which are all the hours that particular generating station has to be operated. Say 1000 megawatt generators, 1000 megawatt generators, how it has to be operate, for how many hours it has to operate, which say in the particular generating station, that for managing 1000 megawatt, it might be, say, hydro. If you take, it might be of four generators, four or five generators. 200 into 5, 200 into 5, that is 1000 megawatt. So which 200, which generating units? So first generating, second, third, fourth, fifth. So which generating unit it has to operate for the which particular time, like that they may give the schedule for that each generating units. So based on the output from that thing, so that that generating units also easily they may generate for whichever. So first generating unit for 3 hours, second generating unit for 5 hours, third generating unit for 8 hours, fourth generating unit for 12 hours. Like that, they may go for combinations, so that easily that job also will be